Okay. So yesterday we talked about the use case narrative, and I mentioned that it is the second part of your use case model. And the purpose of the use case narrative is to provide detailed information that will be lacking in your use case model or your use case diagram. And I said, combine, they help you document the critical aspects of your system, especially showing how actors, how different users would use your system. These users can be people or things or group of people or groups of things. So in the narrative, I used a template to show you how you'd complete a narrative, a use case narrative. And we saw how you'd fill out the ID, we looked at a basic flow, right, and an alternate flow. Okay. So we'll be continuing from there today, just talking about the benefits of your use case model or of use case modeling. And we have touched upon this when we started to talk about use case. But now that we've talked about use case, it makes sense to look at it again and drive these points home. So use case models, including the narrative, provide high-level view of a system. So essentially, they are summarizing the functionality of the system we want to develop, or even an existing system, in case you want to use them to represent an existing system. So they are summarizing the functionality. As you can see, when we talked about use cases, right, we did not discuss the activities in the use case. So it's just a summary. We're not going into the details of the activity in the use case, except when we get to the narrative, we start laying out the step by step and the interactions. So use cases help us summarize functionality, and they provide a way of determining the scope of our system. So by looking at this use case diagram, for example, we can get a sense of all the key things that actors will be able to do with this class registration system. Okay, so we can get a sense of the things actors will be able to do with the class registration system and the actors that would use the system. Use cases also organize requirements from the viewpoint of the user, right? So use cases is the first place where we start looking at requirements from the viewpoint of the stakeholders or the people that would use the actual system. Okay. So a use case is a recipe telling us how, a recipe for how we would make something, right? How we would make the system. So each of those components tell us how the system will be prepared. When you combine it with the narrative, that's when you have that complete recipe. If you just have use cases, like in the case of the diagram, then what you have is a list of ingredients, right? You're just telling us what will be contained in the system or the things the system will do. We are not telling us how the system will do it. So with the narrative, we get that full message. That's why you see with the scenarios talking about the interaction, right? Success scenario or basic flow or normal flow, whatever you want to call it, or whatever your template calls it. And the exception flow or alternate flow tells us how all these things will combine to function, right? All the activities that will be involved in carrying out each use case. So use case including the use case narrative, forms a recipe for our system will be created. Use cases also help us explore alternative scenarios. So, and you can already see that although there will be an assignment that would help you personally explore that journey yourself. So you see that use cases, and especially the narrative part, helps us explore alternative scenarios, right? And we did something like that yesterday, where we started considering what can go wrong, right? So, for example, in the password case, we said, what if the user enters the wrong password? So we start considering all these alternative scenarios and start figuring out how our system would behave if those alternative scenarios occur. So it's in use cases we start thinking like that. Whereas in the other modeling techniques we've used, context diagram and mind maps, we were not considering alternative scenarios. There was nothing about behavior. We're looking at, for the context diagram, how information passes through the system, or the basic information, and the external entities interacting with our system. By the way, and this is an aside, let me just throw it in there for you. Your context diagram is also called a data flow diagram, DFD, a data flow diagram. The only thing is, the data flow diagram that will qualify as a context diagram is a level 0 data flow diagram. So data flow diagram is used to represent the flow of data or information around a system. Right? There are levels to it. There are at least 3 levels, level 0, 1, and 2. The one we call context diagram is the lowest level, where you are not showing the inner workings of the system, right? And so your context diagram is a level 0 data flow diagram. So it's just showing the external entities and the information passing through them. There are different modeling techniques. You can't know, you can't focus too much on all of them. There are plenty, right? So who knows? You may not need these modeling techniques. You may be in a space where you won't even need any, and you may be in a space where you need one of all these that we're teaching you. So when that time comes, we'll see. But at least knowing the whole concept of modeling and how everything works will give you that capacity to quickly learn any one that may be different from the ones you already know. That's if you ever find yourself in an environment where you need to learn a new one. Okay. So we have used these 2 to 3 different modeling techniques, mind map, context diagrams, and none of them considers any alternative scenario, right? But with use case modeling and the narrative, unfortunately, is the narrative that really gets into the alternative scenarios, right? But the use case models themselves, at least they touch on extensions, right? These extends that, this includes that, giving us an idea of possible scenarios, alternate scenarios, like this may happen, but the narrative now gets into the details of it. So use cases begin to help us explore alternative scenarios that may occur for our system. Use cases start the analysis of classes. So you see our use case models and the narrative that comes with it helps us exploring what we call classes, which is another modeling technique. Class diagrams is one of the modeling techniques in UML, Unified Modeling Language. And it's one of the ones we'll be dealing with in this course. So class diagrams are important because they are very, very close to programming languages. They are the most implementable, meaning if we talked about requirements as landing a plane. I explained that you have collected all these requirements, high-level requirements from business stakeholders, right, as words, or even you recorded their voice or voices, and you are beginning to translate these requirements into models, right? And as you are translating them to models, you are landing, you are coming down, you are descending the plane. You are trying to land the plane. The plane lands when you translate it into a model or a representation that your developers can immediately pick up and implement. Okay, so assume that the business people are speaking a different language. So whatever they are speaking is so high above the developer's heads, and you are now translating it. Maybe you don't perfectly understand the developer's language yourself, right? You don't perfectly understand it. It's not your first language. So let's assume you understand, let's assume the business people were speaking French. Developers understand English. You have many languages you understand, maybe your own native tongue, being in Nigeria. So you learned French, right? You as the BA, you have learned French. But in order to translate this French to English, the way you learned French is that you have to first translate it to maybe another language. Let's say, which other language can we, let's use Hausa. Then from that language, you now translate it to English. So each step of the way, you are bringing it down. Let's assume some of the business people that understand French, some of them can understand some of these Hausa. So by you translating it to Hausa, it's still good. It's okay for them. They can at least understand what you are saying. Well, by the time you bring it to English, the developers become your best friend. They can now understand what the business people said in French. That's essentially what you are doing. You are taking this description in a different language, in a business language, and you're trying to break it down slowly to what will now eventually become what the developers can understand. This Hausa language, breaking it down to Hausa, and I'm using this as an example, is still useful for business. It's useful for maybe the middle level managers and some other people, that this Hausa is sufficient for them, but it's not English yet. And so the developers cannot immediately implement it. They don't know exactly what you are saying till you bring it down to their level, and that's what you are doing. So this class diagram, which is one of the models we'll be looking at, would help you bring the requirements down to what can be immediately converted into code. In fact, when we get to class diagrams, I will remind you of this again. There are some environment, there are some softwares that allow you as a BA, that welcome you as a BA to model in class diagrams, and those software will convert the class diagram for you into code, into programming languages. So, and the goal of the developers of those software is to make sure that in the future, which has started happening already, BAs may be able to replace developers, may be able to replace programmers. So BAs can just speak to business, understand what business wants to do, and model it. And those models will convert to code. We're not getting into that. So in case anybody's afraid of programming, don't think we're going to be doing programming or talking about programming, or that you will do anything involving code. No, I'm just saying that. So this, your modeling, some softwares exist that can even help you convert it to code. So to tell you that the models, the final model you create is so useful to developers that when they see it, they can immediately understand and write their codes without any confusion once you do it well. And that's what you want. Okay. So your use cases will form the starting point for analyzing classes. Classes tell us the structure, the way the system, they are like building blocks. You see their shape, squares or rectangles. They tell us what makes up your system. Okay. So classes tell us what your system is made up of. They help us show the structure of your system. Okay. So use cases are the building block for analyzing your classes. Okay, good. Everyone is muted. Now, your use cases also help us define the user interface. And this is easy to understand. Use cases help us define user interface. User interface is what the user will see, right? The part of the software a user will interact with. So an interface is anything that allows two different systems communicate. So I'm saying two different systems, but let me switch it and say two different entities. A user interface is something that allows two different entities, an interface is something that allows two different entities communicate. So when we say user interface, the assumption is that the computer is one system, or your technology, your IT is one system. So the computer with the software, right? The software is one system. Then the person using it is the second entity, and they need to communicate. So the software has a user interface that allows the user interface with the system, allows the user communicate with the system. So your user interface may be a form, maybe something that provides information, or a form where the user can enter information for the program, for the computer to use, right? Maybe a button. So you are using maybe Zoom now, you're using our website. You can only use our website because it has a user interface. It has a form telling you to click this, start your course here. That's the user interface. And that interface allows human beings communicate with the system, with the computer, where all these things, all these code that is showing you what you can see today, where they reside. So if it's computer communicating with computer, they don't need a computer communicating with computer will not need a form or a button. They may just send messages to each other or codes to each other, and they'll do their work. Different computers can just send messages or codes. They don't need a form where one computer will have to go and click submit. Nothing like that, right? But for human beings, there's a user interface. So it's an interface that allows a user communicate with the software or the application or the computer. So there are other interfaces that allow computers communicate with computers. Those may be gateways, maybe through an API, stuff like that. So your use cases help you define user interfaces. Now, in standard organizations, you'd have designers designing these interfaces, right? Designing the look and feel. So how the system will communicate to human beings. You have designers called UI expert or user experience experts, right? These who are responsible for designing how a user will use the system, right? So what a user will see first, what they will do, where the buttons will be placed. So you have all those professionals in a standard organization that will do that. But how will they know what to do in terms of what windows should be available? You as the BA, if you have done your modeling using use case modeling technique, you can provide that kind of information. Your use case can help the developers, the user interface experts, UI designers, they like to call themselves, or UX, user experience experts, would help them know what interfaces are needed. Remember, for when we were looking at use cases for ATM, we said withdraw cash, deposit funds. When we're looking at Winnie's online shop, we said buy fabric. That should tell you that there should be a place, there should be an interface for people to buy fabric. There should be an interface for people to customize what they want. There should be an interface for people to buy bags, right? You can decide to put all those things on the same place, but there should be a way for customers to communicate with the system that they want to do those things, those use cases. So those use cases gives designers an idea of the functionalities you want to be present in your system. Okay. So they are a starting point for user interface or user experience design. Okay. Use cases also form a basis for testing your application. So you can create test scripts through them, or since you already know that these are the ways users want to use our system, that's what your use case represents, right? The ways users, different actors want to use our system. When the system is fully developed, you can check if those goals are accomplishable through your system, through the system. So when developers come and say, we're finished building this system, you can immediately check, okay, can the system allow us withdraw cash? Let's test it. Can the system allow us deposit cash? Let's test it. Right? So these use cases would help you in knowing what to test for when the system is deployed, so they can form a basis for testing. So modeling is good, right? A noble, logical model. I told you can replace the word model with diagram. Once recorded, will never die. I like that statement. That's why I put it up, obviously. A noble, logical model, once recorded, will never die. You see, if you write the requirements, or if you just place it the way the stakeholder has said, right, people may interpret it in different ways. Some of us are familiar with people interpreting something written in text in multiple ways. In fact, many times that's why the Supreme Court exists. People will argue and argue and argue, and they will take you to the Supreme Court to interpret the law. They'll say, what is the interpretation of this law? Because we can interpret it in this way, and someone else is interpreting it in another way. So let's go and settle it at the highest level. We'll push it till we get there, so that the panel of judges are not just one of them, because one is not enough, because everybody may see the same thing written in text in different ways. So that's why in the US, for example, I think is 9 or 7, and I don't even know the number, right? And they will now vote on the interpretation that text you have. So you see, text is not reliable. In fact, as time goes on, one particular text that meant something this year may mean something else next year. But you see, with modeling, when you model it, you use those simple circles and squares, simple circles and square. We can't interpret it in two ways. As long as you have modeled it well, we cannot interpret it in two ways. Right? We have done our work well enough. Using all these, you see those include and extend. You see those simple things. That's why we do not use plenty languages for model. Just simple things, square, circle. That if you can use those square and circle to explain what the system is about or what the system needs, it cannot be misinterpreted. Nobody will come and say, but you put your comma here. At the minute you put the comma in the next place, it will mean something else. But the comma is here, so it means something else. Right. There's no comma in modeling. So a noble logical model or diagram, once recorded, will never die. 300 years from now, as long as the people reading it understand the modeling technique, clear, no misinterpretation, they can implement that system. And that's why modeling is good. Okay. So assignment 3. Assignment 3 is, you see the Amazon website. Draw a use case diagram for the Amazon website. Okay. So process modeling. Now, before we start looking at what process modeling means and what processes are and all those things, I just want to say, you see what we did with use case models, where we created a use case model and we had to create a narrative for the model. Process modeling is the logical next step. It doesn't mean that if an organization is saying you should do use case, you have to do process model. No, there are two different things doing two different jobs. But one advantage process models have, and that's if you need that advantage, if your organization wants you to model that way to explain a process or something, is that you see what we are doing in two different steps in use case diagram, where we model and we create a narrative. For process model, you can put all those things in one model. So all those alternate flow, all those other things, they can be in one model. Unlike use case, where the use case just captures how users want to use the system, it doesn't tell you the step they are going to take to perform the use cases. Your process model tells you those steps and captures the alternate flow. Your use cases does not capture alternate flow adequately, but this one captures it. So you need use case narrative. This one, you don't need any other thing. Your use cases capture, your process model captures what your use cases does not. And that's why process models are popular. But you see, these two modeling techniques do different things. And like you'll notice, all the modeling techniques I've discussed do different things. They are providing different levels of information, different perspectives to your system. The context diagram provides a different perspective than the mind map. The mind map provides a different perspective than the use case model. The use case will provide a different perspective than your process model. So it's either one is making the other, one is more detailed, or one is looking at the system from a different view, right? And that helps your different stakeholders be able to understand your system. So if a stakeholder does not understand context diagram or context diagram is not sufficient, the mind map will be sufficient for that stakeholder, or the use case model will be good, or your process model will be good. And if process model is not useful to the stakeholder, or if all these models is not useful, we'll add another one. We'll talk about another model next, the class diagram, which is the most closest to actual implementation of the system. So all these different models is to make sure, while we're teaching this, while I'm explaining all this, is to make sure you can represent the system in a way that know how your stakeholders will be able to understand the message you are trying to pass across concerning the system using any of the models, depending on what kinds of information they want or what kinds of information they need to get to have. So let's look at what business process modeling is. Business process modeling, number one, is one of the most popular modeling techniques you will find for organizations that use modeling. Well, first, what is a business process? A business process is a set of logically related tasks performed to achieve a defined business outcome. Let me explain it another way. A business process is the set of activities or tasks that you would perform to accomplish a use case. Right? So a use case, for example, is I want to withdraw cash, right? So what are those steps you perform to carry out that use case? That's what a business process is. The process of withdrawing cash is a business process. The process of depositing cash is a business process because you are achieving a defined business outcome. So one example we looked at in the beginning of this course was the cake example. And we said for cake, for example, you have different inputs, your flour, your sugar, your milk, your butter, and all those ingredients. And the output will be cake, right? But there's a process that the baker must take to make this cake. Different organizations may have different processes. Even organizations that produce or supposedly produce the same thing, like organizations that sell burger, McDonald's, Burger King, all those places, right? It's all burger. They buy the bun, the burger patty, and all those things. But their processes lead to unique output. Even organizations that sell chicken, different types of chicken, fried chicken, the processes will be different. So organizations can customize their process to affect the output. Okay, the input is exactly the same. It's chicken. There's no one that is heavenly chicken or chicken grown in grass. Right? It's all chicken, but the processes will make one chicken taste better than the other. So process is important. And modeling the process is also very important. So representing the process of carrying out an activity where boss understand how the activity or that business outcome is achieved. Now, I remember Shegun mentioning, one of our instructors then mentioning that many times you need to tell the story of how your business outcome starts. And it was in relation to something Winifred said when she was giving an example of how she did something in Evolve. Business process modeling is that technique you use to represent the beginning and the end of a business outcome. So when you hear people say, can you model the end-to-end of a solution or the end-to-end of a software or the end-to-end of a business function? End-to-end is just telling you business process modeling. So process modeling, can you model the process from when this business function starts till when it ends. So what they are saying is, can you do process modeling? Can you do process modeling? A process is a structured, measured set of activities designed to produce a specific output for a particular customer or market. So a process is a set of measured set of activities designed to produce a specific output. Customers come into a bank to withdraw cash. So there is a set of activities that has been designed to ensure that they can withdraw their money. Right? They walk into the bank, they talk to a teller, the teller collects information, certain information, uses it to check their system and checks how much they want to withdraw. Maybe they feel a withdrawal slip. Can you model that process? That is a process. Can you model it? That is what has been modeled and automated to create the automatic teller machine. So somebody looked at that process and now automated it, now computerized it to create your ATM. So can you model business processes? So modeling the end-to-end just means the beginning is an end, right? Then the other end, so end-to-end. Can you model the end-to-end of a solution? Now, when it comes to solution development or software development, there are two key ways you would use process modeling. One is you would use process modeling to model the current state. That is how a certain business outcome is being achieved, or how a certain business process is currently organized or being carried out. So that's the current state. The current state is also called the as-is. As-is, as it is, shortened to as-is. So you would hear in business analysis speak that, can you model the as-is, or please model the as-is of this system? What they are saying is model the current state. That's how this thing is working right now, the way it is, before we improve it, before deploying your system or your solution. How is it working right now? So model that. Then another thing you would use process modeling for is to model the future state. That is the to be. The to be. So they say model the as-is and the to be. That is the current state and the future state. So there are different ways to do process modeling. There are different techniques that you can use to do process modeling. One of them is in the UML, is in the body of UML language, is called activity diagrams. That's one way to do process modeling. Activity diagrams. Another one is called swim lanes. So many times when people are talking about process models, they mean you should do swim lanes. Swim lanes is the easiest. This animation you are seeing is an example of a swim lane. Start, then whatever activity would happen is represented in this rectangle. So activities are represented in rectangle. Start and end will be represented in using an oval. Then you have decisions represented using this diamond shape. So swim lanes is the easiest way to model processes. It's straightforward, simple. And we'll look at swim lanes. We'll see using maybe one of our tools to model using swim lanes, just so that you know it. But instead, even if time doesn't permit, we'll go to one that is a bit more, something in the UML body of languages that is a bit more formalized, a bit more standard than swim lane, which is the activity diagram. Now, they are very, very similar. So if you can model activity diagram, you can definitely model swim lanes, right? A third approach is called the BPMN, business process modeling notation. Business process modeling, which is what we're doing. The N stands for notation. So this is another standardized approach, very standard, developed by the same people that created the UML languages, but it is outside the UML. It's separate. It's so, boss level that they created his own separately. Again, if you can model activity diagram, you should be able to model BPMN. BPMN just adds some extra, and you will see it. So if time permits, I can do the three for you if we have the time. So you see them and see how it works. If you can model the middle one, you can model the lowest level, and you can model the highest level. So let's focus first on getting you to understand how to model activity diagram. But when people ask you to model processes, it may make sense to just use the easiest one if they are not specific. So just use the easiest one, which is swim lanes. But you would see that is the same thing, just minor differences. So where this one uses this shape for start, activity diagram will use pure circle instead. So that's like the difference. So when you go on your tool and you say you want to do activity diagram, it will bring the shapes out that you can use. So you would see, oh, this one is not oval like this. This one is using circle. So you don't need to bother yourself. As long as you know how to model, you'll be able to use anyone. So let's look at activity diagram. In fact, I may show you activity diagram and decide to model using BPMN just on the tool, or decide to model using swim lanes. So, but for the sake of the lecture, let me show you activity diagram. Now, looking at this picture that we have here, this is an example of a process model. This model that you see here, if I tell you that is activity diagram, or if I tell you that is BPMN, you can't know the difference. You can't say anything is wrong, because all the symbols I've used here are exactly the same for both modeling technique. There's no symbol here that is different for BPMN or activity diagram. They are exactly the same, these symbols here. I'll show you another model in the next video. You see this, the way this looks is exactly the same for BPMN and activity diagram. The is different for swim lanes, and the difference is for swim lanes, the start will be like bigger circle over, the end will be bigger circle over. So that's the only difference between them. This shape may be bigger if it's swim lane. It's the same shape, but the size may be bigger. So you get why I say if you know one, you can do the others. So let's see how you would use process modeling. So end-to-end business process, right? The start to the finish of a business process. Now, your process model helps you model business processes at a high level, showing steps from end to end. Your process model helps us provide context for use cases. So extra information like what should be done first, right, that you won't find in a normal use case model. Your process model will show you who does what first. You won't find it in just the use case model. That's why we had to add narrative to it. But your process model will show you that. So this initial node is big grammar. It just means the start, the beginning. And this final node, you see the difference? There's a circle inside and that circle. So not just solid dot, is the end. Now, if it's process for a typical swim lane, or what, when people say process model, many times they mean that lowest level swim lane one. That's what they mean most times. But you can actually use different techniques to do process model. So I'm just showing you one of the techniques, activity diagram. So for your swim lane, so I may call it process model from time to time, you should get what I'm saying. For your swim lane, the difference would be you are using the same shape that you use for start as end. You will just write it in its end, start. That's the difference. Every other thing here is the same. So this says start, this symbol says end. Then you show the processes. So when you start, these arrows show the flow of operation in your or the flow of activities to achieve your use case. So this rectangle will contain an activity. Maybe for withdraw cash, the first activity is insert card, right? So you write it here, insert card. Then what happens next? You write it here. What happens next? You create an activity. And if there's a decision point, like an alternate flow, for example, if the pin is correct, then take this next step. If the pin is not correct, maybe go back and say insert card or enter pin. So you see, we can model alternate flow using this same system, this same model, rather than having to write stories as a narrative in another document. So this is your process model. So let's see an example. So this is assuming a blog or your YouTube website where people can comment, and you want to be able to moderate the comments before the world can see it. So when people submit comments or on your website, you want to keep the comment till you see it and approve the comment before the world can see it. So how will that work? Let's read this. Now, the actors in your process will be splitted into, will be divided into what we call swim lanes. So this is a swim. We'll still show you, I'll still show you all this. So this is a swim lane, this is another swim lane. So each actor will be divided into swim lane. And the reason is you want to know which activity is performed by which actor. Okay. You want to know what actor is doing what other actor is doing what. And you also want to know how activities flow in the process. You see, this process model is so good, it's so interesting, so powerful. This is an entire domain on its own. If you want to, for people that want to specialize in it, process improvement. This is an entire domain on its own that is beyond what we can cover, is beyond what a business analyst will know or what a business analyst will do. You can have people that their job is just to improve processes. So they will go into, say, like a retail shop or a bank and look at how activities are being done and model the activities like this using diagrams like this. We now have softwares that you can enter the time it's taking for people to perform each of these activities. So we can now figure out how can we reduce the time spent. What if we cancel this task? Or what if can we do without this task? Can we remove this task? Can we replace it? That's process improvement. That is another aspect of just using process modeling, which is beyond what a business analyst, a new business analyst, or a normal business analyst will specialize in. So depending on where life and career takes you, it may be that you develop interest, you become so very, very good in process modeling, you develop interest in process improvement, and you go specialize in that in future. And those kind of people can re-engineer the process of an organization. You can look at how an organization is carrying out some activities and re-engineer it to make it faster and easier. So, but that's a different thing. But for your system, let's get back home to systems. So each actor will be divided into swim lanes so you can see the activities they perform. Okay. So let's try to interpret this process model. Let's assume that an author, somebody posted a comment to your blog or your website. So the person is an author, right? So the author starts, the whole process starts here. The author opens an article, publishes the article. So we're calling what they are posting. Let's call it comment. Creates a comment, publishes it. The moderator, maybe the owner of the website, can moderate the comment after they are published. So we can see the arrows flowing. So it's after they are published that the moderator will moderate it. And if they approve the comment, they can set it to publish so the world can see it and the process ends. If they don't approve it, they will reject it and the author will be notified that the article has been rejected and the process ends. That is a way to interpret this article. This is actually written for people that publish articles like research. So this is the process. You open an article, you submit it, someone checks, they approve it, it's published, they reject it, you are notified that it's rejected. And you see the process can end after you have been approved or end after the article has been rejected. So that's how you interpret this. So this process model helps us visualize a use case as a set of activities. Look at this other one. Let's assume a pharmacy. The story starts where all good story starts at the beginning, right? That's why we have the start symbol. So a pharmacy receives an order and they can choose to accept the order. If they accept the order, they will fill the order. So see where I'm going. They fill the order. Now, this is an activity diagram. How do I know this is an activity diagram? You see, because of this symbol is not present in most of the other approaches, but you can easily replace it. So it's not a problem. So let me show you what the symbol is doing. So this symbol is called a fork. I will see that in the next slide. Yes. So it's called a fork, and this is a join. What this does is it splits the process into two concurrent processes, meaning two processes that are happening at the same time. So what this is saying is the pharmacist or the pharmacy receives order, decides to accept the order, they may decide to reject the order. But we're going with the first flow, right? So they decide to accept the order. The next activity for them is to fill the order. When they fill the order, two things would start happening. They will send out an invoice. This is the invoice. They accept payment, right? But at the same time, they will ship out the order. As they are sending out the invoice and accepting payment, they're also packaging the medication. So then we have this join node to say, okay, these two processes now join together here. And then goes into a decision node to merge them, a merge node. And then the order closes. That is the flow here. That's what this represents using activity diagram. Now, the alternate flow is here. If the order is rejected, if the pharmacy says maybe we don't have that medication, you see, you just go straight to merge and end. So this merge node here is just to make things neat, so that instead of having all these arrows point to end straight, so this one arrow point to end, this other arrow point to end, then this, close order. This arrow points to close order, this other one points to close order, then close order to end. The modeler decided to add this diamond symbol, which is for decision, right? To use it as a merge. So it brings all these arrows together, then just one arrow comes out to close order. Right. So you could as well have just pointed all these to close order and you won't be wrong. It's just that you decided not to use the diamond symbol to merge. Right. Now, what is the difference? You see this fork node and join node. In other models, other modeling technique, you can, like, especially BPMN. BPMN has different variations, is the most advanced, different variations of this decision symbol. So you can have this same decision symbol, but BPMN may have an extra sign under to say this one is for dividing things. Then we have another decision symbol that is for bringing things together. They can put down a plus. That is to bring things together, to merge things. So instead of this fork node for BPMN, you may use the decision symbol that is for dividing things. And you use a decision symbol here that is for bringing things together. All right. That's the difference. So you can replace this with the symbols in BPMN that do the same thing if you need to. So let's move on. So these are the components of your activity diagram. You have a start node, you have a final node, end, start, end. You have your activity node, which is just a rectangle with curved edges like we used. You have your control flow, which shows how things are flowing. You have your decision, is also called a branch. All right. It's also called a gateway. So depending on the tool you are using, the key thing is recognize the symbol and what it does, regardless of the name they call it. Right? So it's called a decision, it's called a branch, it's also called a gateway. Principally is used to make decisions, but now some other tools use it to also split, because you can have an arrow coming here instead of having multiple arrows going down. You can just have one arrow coming here and it splits into two arrows, right? So you can use it to split. You can use it to make decision. Maybe this is yes, this is no. Like, are you hungry? Are you hungry? Yes, no. So if it's yes, do something. If it's no, do something else. So you can have it like this. You can use it just for the sake of splitting, no, yes or no, just to show that this one thing we split into two different operations. So BPMN will now put a symbol to show that you are not making a decision. You are just splitting. So you can use it to split. You can use it to merge too, and bring these two arrows together inside it to say these two different processes have brought them together and they join to form one process going forward. So now, will your own process require you to split or merge? We don't know, right? It depends on what you are modeling. So you don't need to be worried about, will I need to split something? Will I need to merge something? You will know when you are modeling whatever it is you are modeling. So when you are modeling something, you say, okay, at this point, two things will happen. Two things at the same time will happen. So you know you need to put something there that will allow you split. And that's where this decision or branch or gateway symbol comes in. Now, for activity diagram, you have this fork and join, which helps you with the splitting instead of this decision. Decision just does decision in activity diagram, but the fork and join helps you split. Fork, split, join brings together. Then your swim lanes, which is where you put each actor's activity. Now, all the swim lanes will be contained in what is called a pool, right? So a swimming pool, like Olympic size swimming pool, we have different lanes, swim lanes for different people to swim. If one player that is supposed, one sports person, one swimmer that's supposed to be swimming in a lane decides to cross to another lane. That is a foul, right? It's wrong. So that's the same thing. You have a pool and you have swim lanes where each actor, all their activities are supposed to be contained within their own swim lane. So the whole combination of the swim lane will be called a pool. Now, interestingly, as you can see, we're talking about swim lanes here, 1, 2. A process modeling technique is also called swim lane. That is the easiest one I talked about. Is also called swim lane. So I guess people, it's so easy and people are so lazy with the name that they just say, you know, that one you can use to draw swim lane. So they just started calling it swim lane rather than even giving it its own name. So it's called swim lane, the easiest one, where you are using normal basic shapes, right? So let's see if we have, okay, we still have some time. Let's see how we can draw. Let's go to a tool now and draw a process model for ATM withdraw cash.
Oh, for me, no question.
Sorry, what?
I said there's no question for me.
Okay. No question. Does anyone have any question? Any?
No question for me.
Okay. Okay. We've gone very far. We've even gone past the time I wanted us to end, but I wanted to show you at least 2 of these different types of 2 techniques that can do this, so you are aware of the slight differences between them, and so you are not worried if someone says, can you do swim lanes? You'll be able to say, yes, I can do swim lanes. As long as you can you do activity diagram? Yes, I can do activity diagram. And if time permits, I would do something with BPMN, but it's the same thing as doing your activity diagram, the same symbols. Okay. So this is BPMN. Tasks. Okay, so I won't take you through this. I won't bother you with this tonight, but I just want you to know that as long as you can do one swim lane type or one process modeling type, you can do the others. Okay. So this is a good place to stop, and we'll continue tomorrow. So good night, everyone.
Good night, Prof. Good night, everyone.
Good morning.